Howdy, students. This is the final week of the course, and my goal here is to synthesize what we've learned this semester into a coherent climate policy. Let's begin by reviewing what we know. We know the Earth is warming and that human activities are mainly responsible. We also know that predicted climate change is large enough that it could literally remake the face of the Earth during your lifetime, and the impacts of this could be severe. You should be familiar with and understand these points. In the Paris Agreement, the world agreed to limit the warming to well below 2 degrees Celsius with an aspirational goal of limiting the warming to 1.5 degrees Celsius. Importantly, these temperatures are all relative to pre-industrial. As of early 2020, the Earth has already warmed about 1 degree above pre-industrial, so limiting warming to 1.5 degrees means we're only allowed about 0.5 degrees of additional warming from 2020's levels. Given that the planet is warming a few tenths of a degree per decade, we'll breach the 1.5 degree limit 10 to 30 years from now and the 2 degree limit around the middle of the century, unless we take aggressive action to reduce emissions. Let me talk a bit about these limits. Don't take them too literally. We do not expect 1.6 degrees to be a whole lot worse than 1.5 degrees, and 2.1 degrees will probably not be much worse than 2 degrees. So don't view these things as magic limits that, if broached, catastrophe will ensue. Nevertheless, we can reasonably assume that more warming is worse than less warming, and the difference between 1.5 degrees and 2 degrees is significant. The IPCC wrote an entire report on the 1.5 degree target, and they concluded that there was high confidence that there's a robust difference between impacts at 1.5 and 2 degrees. Despite the fuzziness of these targets, you still have to specify them if you want to write a policy. These long-term goals are ultimately compromises between what we want, as little warming as possible, and what's achievable. Let me emphasize here that these limits are not just based purely on science. Certainly, science is an input. After all, you can't really make a policy if you have no idea how much warming will occur and how these will impact things we care about. But value judgments also play a huge role. What value do we assign the welfare of future generations compared to our own? Do we care if polar bears go extinct? What value do we place on leaving the Earth unchanged for future generations? People can argue about these points, and they will determine how much effort we put into stopping climate change. In Chapter 8, I showed you this slide, which shows future climate projections from computer simulations of the climate. Note that these temperatures are relative to the late 20th century, so you should add about 0.6 degrees to get temperatures relative to pre-industrial. These were determined by making estimates of population, affluence, and technology under different economic scenarios, and then using those to determine emissions, and then inputting those emission scenarios into computer simulations of the climate system in order to estimate how the climate changes in response. However, there's a different way to look at climate change. We can start with a target, say 2 degrees Celsius, and then ask what emissions trajectory would be needed to achieve that. To do this, we first need to understand what's known as a carbon budget. It turns out that because of the very long lifetime of carbon dioxide in our atmosphere, which I harped on ad nauseum in Chapter 5, the peak warming we experience will be equal to the total amount of carbon dioxide emitted into the atmosphere since the Industrial Revolution. This plot shows the relation as determined by computer simulations of the climate system. The red star shows where we are about now. We have emitted about 420 gigatons of carbon since the Industrial Revolution, and we've experienced warming of about 1 degree Celsius. Using this relation, we can figure out how much carbon we can emit into the atmosphere without breaking the budget for 1.5 degrees Celsius and for 2 degrees Celsius. To limit warming to 1.5 degrees, we can only emit another 158 gigatons of carbon to the atmosphere. At the present rate of emissions of about 11 gigatons of carbon per year, that translates to about 14 years. This assessment, by the way, is the source of the oft-repeated mantra that we have 12 years to save the planet. I don't think that's a particularly good way to think about it because, as I said above, these limits are not magic. If we can limit warming to 1.6 degrees, that won't be much worse than limiting it to 1.5 degrees. A limit of 2 degrees Celsius has a correspondingly higher carbon budget, 409 gigatons of carbon emissions, which translates to about 37 years at our current rate of emissions. I have not discussed a lot of the details of these budget calculations, and the estimates can be quite complicated and filled with assumptions about climate sensitivity, confidence with which we avoid the target, what you do about other greenhouse gases, etc. These details can make a difference of a few years, but the overall message is robust. We have little time to waste. In order to have a reasonable chance of reaching either the 1.5 or 2 degrees Celsius target, we need to begin deep reductions in our greenhouse gas emissions very, very soon. In the next video, we'll talk about what needs to happen to make these budgets a reality. And now, your moment of dog.